Okay, here is our most important thing for the rest of pre-calculus. Okay, this is called the unit circle. The unit circle. It's called the unit circle because every point along the edge of this circle is exactly 1 unit away from the origin. Okay, that's why it's called the unit circle, because the radius of this circle is 1. Right? 1 mile, 1 meter, 1 centimeter, 1 inch, 1 light year, whatever. Right? It's 1 unit, whatever your units happen to be. So that's important to remember that it is 1 is the units all the way around. Every radius of our circle is 1. So let's talk about the degrees. The degree measure of each of these lines, right? They're all going to be lines that we're going to use. So our first degree is, of course, 0 degrees. And all the way around the circle is 360 degrees. So 0 is the top one on the inside line with a degree symbol. And then the bottom one is 360 all the way around the circle. And since it is 1 unit away, the coordinate here is 1, 0. Right? This point right here is 1 unit away from your origin, so that is the coordinate point 1, 0. Now, as we go up, we're going to make this the 30-degree angle, a 45-degree angle, and a 60-degree angle. Okay, we'll talk about why we're doing 30, 45, and 60 in a minute, but just know that it's about geometry and special right triangles. Okay, and then at the top, this is 90 degrees. Okay, and then as we come down, this is another 30, so this is 120, and then this is 135, and this is 150. Okay, also because of your special right triangles, 30, 60, 90s, and 45, 45, 90s. And then our last one here, halfway around the circle, is 180 degrees. Okay, so these are the degree measures of the top half of your unit circle. Okay, and then there's corresponding ones on the bottom half also, because of 30, 60, 90 triangles. This is going to be 210 and 225 and 240. Okay, and then at the bottom, this is 270 degrees, 3/4 of the way around your circle. And then you have another 30 degrees, so 300, and then 315, 330, finally going back up to 360 degrees. So these are the angle measures in degrees all around your circle. Okay, 30, 45, 60, 90. And then add another 30, 45, 60, and 90 to get all the way around, right? There's a pattern to all of these, so learn the pattern and you won't ever have to memorize a thing. Okay, so now let's get to the rest of our, actually let's do our radians for a minute. Okay, so 0 degrees is also known as 0 radians. Okay, so this is our radian angle measure. So let me tell you what a radian is real fast, or real slow, depending on however I decide to say that. So we all know that there is a circle, and every circle has a radius. Okay, so don't judge my circle of being not so circular. Actually, that's not a bad-looking circle. Okay, every circle has a radius. So here is the radius of my circle. Right, it goes from the center to the outside. So this is my radius. Let's say that this is let's just call it 10, right? Maybe that's 10 centimeters. 10 centimeters. Now, if I took this length of 10 centimeters and I laid it around the outside of my circle, okay, so the length of my arc here is the same as the length of my radius, right? Those two lengths are the same. And of course, if you take a straight ruler and you lay it along a tire or something, you have to curve it as it goes up. Okay? So if the arc length, right? This is called your arc length, the length of your arc. When the arc length is equal to the radius, that's the situation that we have right here. When we draw our line back to the origin to create your angle, this is 1 radian. That's how we define a radian. It's the angle formed when the arc length is the same as the radius. That is 1 radian angle measure. Okay? 1 radian. That is how a radian is defined. Okay, a degree is 1/360th of a circle, right? That's how we define that. You take a circle and you chop it into 360 equal parts. One of those parts is 1 degree. Well, this is how we define a radian. And it turns out that if we do another radius, okay, if we lay another radius around the outside here, okay, 2 radians takes us to here. So this is 2 radians. And 3 radians takes us almost exactly halfway. Almost. That's 3 radians. So guess how much is left over there to get to 180 degrees? 0.14159.265. Okay? Do you recognize the number 3.14159.265? That's the number pi. There are exactly pi radians in 180 degrees. Okay? That's what I need you to remember, that there are exactly pi radians, 3.14 angles in 180 degrees. Okay? That's the important number. So let's go back over here to our radian. This is pi radians. 180 degrees is the same as pi radians. So what if I chop 180 in half? I get to 90. So 90 degrees is what portion of pi? If 90 degrees is half of 180, then 90 degrees is half of pi. So 90 degrees is pi over 2. What if I were to divide 180 by 60? What's 180 divided by 60? 3. So 60 degrees is pi divided by 3. What if I were to divide 180 by 4? D5. 180 divided by 45 is 4. So 45 degrees is pi over 4. Because there are 4 45-degree angles in 180 degrees. And what if I were to divide 180 by 30?
6.
That's 6. So 30 degrees is pi over 6 radians. Because there are 6 30-degree angle sections in 180 degrees. Okay? So now it's just a matter of counting. Let's count. Shall we? Yes, we shall. Okay, if this is 1 pi over 3 or 30 degrees, what if I go another 30 degrees? Where do I end? 60 degrees. What's 60 plus 60? 120. So 120 is 2 pi's over 3. 2 pi over 3 angles. Okay, what's 120 plus 60? 180. So that's 3 pi over 3's. 3 pi over 3. What does 3 pi over 3 reduce to? Well, just 1, right? 3 pi over 3 is 1, so that's where we get pi. What if we add another 60? That's 240. That's 4 pi sections divided by 3. That's 4 of those 60-degree sections. Okay, what if I add another 60 degrees? That's 300. 300 is 5 pi over 3. All right, so we are counting. How many 60-degree sections have we gone? 1, 2, 3, 4, 5, 6. What is 6 pi divided by 3? 2 pi. All the way around your circle is 2 pi. 6 divided by 3. Okay? So all of the 60-degree angles are all some sort of pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. We're just counting how many pi over 3s we do. Okay? So let's do that same thing with the pi over 4. Let's count how many pi over 4s we have. Here is 1 pi over 4. Another 45 degrees gets me to 2 pi over 4, which is also known as 1/2. Right? 2 over 4 is the same as 1/2. Another 45 degrees is 3 pi over 4. Another 45 degrees is 4 pi over 4. 4 divided by 4 is 1. Another one is going to be 5 pi over 4. And then another 45 degrees is 6 pi over 4, which reduces to 3 pi over 2. Okay, we're always going to reduce. So the bottom 270 is 3 pi over 2. Another 45 degrees gets me to 7 pi over 4. And another 45 degrees gets me to 8 pi over 4. 8 divided by 4 is 2 pi. Okay? So all we're doing for the rest of our unit circle is just counting. We are counting and simplifying everything that we can. Okay? So now let's go back and look at pi over 6. Pi over 6. So here we have 1 pi over 6. And then we have 2 pi over 6, which reduces to 1 over 3. And then we have another 3 pi over 6, which reduces to 1/2. And then we have 4 pi over 6, which reduces to 2 pi over 3. And then we have another 30, which is 5 pi over 6, right? We don't have that one yet, so 5 pi over 6. And then another 30 degrees gets us to 6 pi over 6, which is just 1 pi. Another 30 is 7 pi over 6. Well, we need that one. We don't have that one yet. So 210 is 7 pi over 6. Another 30 is 8 pi over 6, which reduces. Another 30 is 9 pi over 6, which reduces. Another 30 is 10 pi over 6, which reduces. Another 30 is 11 pi over 6, which we need. Right? We don't have an 11 pi over 6. So our 330 degree angle is an 11 pi over 6 radians. And then another 30 is 12 pi over 6. Well, that reduces also. Okay, so when we're talking about radian angle measures, we are simply counting how many of these 30 degrees or how many of these 45 degree angles have we gone. And you are reducing it to its lowest terms. Okay, so let's put in the final piece of the puzzle, and that is, what are all these points, right? What are in your coordinates? Well, it comes from the fact that we have special right triangles. A 30 degree angle makes a special geometric right triangle, right? It makes a 30, 60, 90 right triangle. So if you think back to your geometry, which was forever ago, I know, no, just last year for a lot of you, you might not have spent much time doing this. My students did, so they were pretty good. But this is a 30, 60, 90 triangle. It's a 30, 60, 90 right triangle. Okay? Every 30, 60, 90 triangle has the same proportions. So we start off with the hypotenuse. The short leg, which is across from the 30 degree angle, is always half of the hypotenuse. And the long leg of your 30, 60, 90 triangle, which is down here, is always whatever the short leg is times the square root of 3. Okay, those are the ratios that always exist in a 30, 60, 90 triangle. Okay, that always exists in a 30, 60, 90 triangle. Now, what do we know about the hypotenuse of that triangle? What is the length of the hypotenuse, aka radius of your circle? The radius is 1. The radius is always 1. It's called the unit circle. The radius is 1 unit. So every single one of these triangles that we make is always going to have a hypotenuse of 1. So if the hypotenuse is 1, what is the length of my short side? What's half of 1? It's 1/2, right? Half of 1 is just 1/2. So if I have a hypotenuse of 1, I have a short side of 1/2. And then what's the long leg of my 30, 60, 90 triangle if their short leg is 1/2? Well, that's 1/2 times the square root of 3. Because the long leg is whatever the short leg happens to be times root 3. Okay, it's a Pythagorean theorem thing that always happens like that. So now let's put some ideas together. The long leg of your triangle is what coordinates? What axis is this horizontal axis known as? What axis is horizontal? The x-axis. If the x-axis is horizontal and your x side is 1/2 of root 3, that means the x-coordinates of this point is root 3 over 2, because that's the horizontal length of your triangle. The horizontal length is always the x length. And what's our vertical length of your triangle? Well, that's got to be 1/2. The vertical side is 1/2. The vertical part of your coordinate is the y part. So the coordinate there is root 3 over 2, which was the horizontal side, and 1/2, which is the vertical side of your triangle. So that coordinate point at 30 degrees is root 3 over 2, comma, 1/2. Okay, it comes from the fact that we have a special right triangle from geometry. Our next special right triangle is a 45, 45, 90. So we have two special right triangles, 30, 60, 90s and 45, 45, 90s, where our angle is 45 degrees. Okay? And whenever we have two base angles that are the same, 45 degrees and 45 degrees, that makes this an isosceles right triangle. So both of these legs are going to be the same, because that's what happens in an isosceles triangle, is two legs are the same. And the hypotenuse can't be the same, so the hypotenuse is what it is. So the hypotenuse is 1, right? The hypotenuse is 1. So how can we figure out what the legs of your triangle are if we know the hypotenuse is 1? The same way we figure out everything from a right triangle, and that's by using the Pythagorean theorem. So let's come down here for a second and do some Pythagorean theorem stuff. We know that the side squared plus the other side squared is equal to the hypotenuse squared. X squared plus x squared. Those are the legs of your right triangle, equals 1 squared, the hypotenuse. What is x squared plus x squared? Duh, 2x squareds, and 1 squared is just 1. So let's solve by dividing by 2. We get 1/2. X squared equals 1/2. And how do we solve a square? By taking the square root. So because it's geometry, we're only going to deal with the positive portion. So we're not worried about the negative square root of this. So what's the square root of 1? Because we take the square root of the top and the square root of the bottom. What's the square root of 1? Well, that's just 1. And the bottom we have root 2. So the side length of my triangle is 1 over root 2, which we don't leave like that, right? We can use our math hack to write this as a rationalized fraction. So the sides of your triangle for a 45, 45, 90, if your hypotenuse is 1, is root 2 over 2. Okay, that's important because those are the coordinates of this point here. Both of these are root 2 over 2. And that happens at every 45-degree angle. The x and the y are always going to be the same at every 45-degree angle, because a 45-degree angle creates a 45, 45, 90 triangle, which is an isosceles triangle. And isosceles triangles have 2 equal legs. So at 45 degrees or at pi over 4 radians, you have the same x and y coordinate, root 2 over 2. Okay? Now we have one more angle, and that's the 60 degree. So now this is the orientation of our 30, 60, 90. So now this is the short leg, which is half of your hypotenuse. Okay? So our legs switch. Before we had a 30, 60, 90, where the horizontal side was the long leg. Now the horizontal side is your short leg. So the x coordinate is going to be 1/2, which is the short leg of your 30, 60, 90. And the y coordinate is now the vertical side, right? The long leg, which is root 3 over 2. Okay? So I want you to take notice of this. These two angles have the same coordinates. They're just switched, which would make a heck of a lot of sense because you're using the same triangle. They're both 30, 60, 90 triangles. Only one, the orientation is their short leg is to the right, and the other one, the orientation is their short leg is down. So your coordinates switch. Okay? Those numbers are the same. You just have to remember which one comes first. And then on top, up here, the x value is 0 and the y value is 1. Because it's vertical along the y-axis, we have a 0 x value and a 1 for the y value. Now, how do we figure out the rest of these? Well, there's a whole lot of symmetry. Okay? If I were to draw this triangle, this pi over 3 point comes directly over to this pi over 3 point. Okay, all the pi over 3's will have the same coordinates. All the pi over 4's will have the same coordinates. And all the pi over 6's will have the same coordinates. But let's talk about what's happening in the second quadrant. In the second quadrant, all the x values are negative and the y values are positive, which means the x value from your coordinates is going to be negative. So this is a negative 1/2. And the y value is going to be the same, a positive. And that goes for every single one of these points. The pi over 4 matches up with its pi over 4, only now the x coordinate is negative. So negative root 2 over 2 and positive root 2 over 2. Okay, the pi over 6 coordinates always match up with every other pi over 6 coordinate. Only now the x value is negative and the y value is positive. So when you learn the first quadrant, every other quadrant is the exact same coordinates, but with a different sign. Okay, same thing for, and then of course we have this one, which is negative 1 comma 0. Right, negative 1 comma 0. So here we have another pi over 6. So the coordinates are going to be the same, only in the third quadrant, both coordinates are negative. In the third quadrant, both coordinates are negative. So all the pi over 4's are going to be negative. Both of them are going to be negative. All of these points in the third quadrant have both negative values, because everything is negative in the third quadrant. Negative 1/2, negative root 3 over 2, and then of course 0, negative 1. Okay, the symmetry is beautiful. And then in the fourth quadrant, the x's are positive and the y values are negative. Okay, so once again, the pi over 3's have the same coordinate points, only the y is a positive 1/2 and the x is negative root 3 over 2. Okay, same thing for the pi over 4, positive root 2 over 2 for the x, negative root 2 over 2 for the y. Same thing for the pi over 6, positive root 3 over 2 and negative 1/2. Because that's the way these things roll in the fourth quadrant. The x's are positive and the y's are negative. Okay, so there's your unit circle. Memorize the first quadrant and learn the patterns. All the pi over 6's have the same coordinates with different signs. All the pi over 4's have the same coordinates with different signs. All the pi over 3's have the same coordinates with different signs. Okay, good job.